Next up, we have Jonathan.
Okay, hello. So I'm looking at a bit of a more molecular synthetic approach to this. So if we go to the first slide there, you can see that I'm using a derivative of a very well-known dye called perylene diimide, or violet pigment number 28, which has been used in various optoelectronic devices such as solar cells or transistors or OLEDs or whatever, lots of uses for it, but it has some pretty substantial downsides, and one of the big ones is the solubility. So what we were able to do in the Welch group is we were able to make an N-annulated derivative, so that's there in the red, and it has some unique properties, especially to do with its solubility. It's very poorly soluble in almost any solvent you can think of. But if we add a base to it, that's either sodium hydroxide or N-butylamine, we can get that into near aqueous solutions. So we can get pretty close to very green processing that is conventionally inaccessible to that chromophore. So what I was looking at doing was extending this project and looking to make it so that we had to use less base and less amine. So I made the series below looking at adding electron withdrawing groups to stabilize the negative charge that we get when we deprotonate. So if we go to the next slide, we can see my results. Basically, the first graph, we're looking at the change in the pKa, so that's the technical measurement of how acidic that proton is, and we can see a very linear trend. The more electron withdrawing groups, the more acidic it becomes. And what's even more fantastic is that that actually applies to our processing conditions. So not only is it a theoretical, oh, we probably have to use less base, but in our actual casting conditions, we're able to solubilize those dyes using a lot less base and a lot more aqueous solvent. So we're moving from a very organic, very potentially dangerous environmental type printing conditions to nearly fully aqueous conditions. Thank you.
Great, thank you. Very well presented. I'll just quickly check to see if there's anything in the chat and give it a second or two to catch up. If not, I did have one question, which is you're heading towards aqueous solvents, and I assume this is for print electronics applications. Yep. Are there any other challenges with using aqueous solvents in these sort of applications, or is it purely a solubility challenge?
From my point of view, it's a solubility challenge. I don't know about the practicality of how easy it is to print from water. From my impression, it's relatively convenient for the common printing techniques.
Yeah, that's cool. Great, thank you very much. Good talk.
Thank you.